For problem number 8 on your review, it's discussing lesson 2.4, where we're talking about parallel and perpendicular lines and how their slopes are related. So remember, parallel lines are ones that have the same slope. They never cross. For example, these 3 equations over here, the slope of each of the equations happens to be 3. That means all of those lines are parallel. They will never cross. Perpendicular lines, on the other hand, they meet at 90-degree angles. It's important to note that if lines are perpendicular, for example, these down here in the picture examples, it could be a vertical line and a horizontal line, just like your X and Y axis is, or it could be a line maybe more like an X. It could be slanted a little more, maybe not. Notice how one of these lines is going up to the right, so it has a positive slope, and the other one is going down to the right, so it have a negative. Unless the lines are vertical and horizontal, one of them will always have a positive slope and the other one will have a negative slope. That's why we say the slopes are opposite signed. Slopes also have a special relationship called a reciprocal or flipped relationship. Take, for example, these 2 lines here. If the slope of this positive line is 5/3, the perpendicular slope, which we sometimes note with this symbol, the upside down T, perpendicular, it would have a slope that's negative, since the first one was positive, and notice that it's 3/5 now. We call this flip of our numbers a reciprocal. Opposite reciprocal slopes are what perpendicular lines will have. So on problem number 8, you're asked to create equations that have parallel, perpendicular, or neither slopes to the lines given. Another quick note about parallel and perpendicular lines: point slope might be your easiest equation to use. It may seem like the most difficult, but for example, in your packet you tried one like this where it said you want a perpendicular line to the line -1/4 x plus 11. So the perpendicular slope being the opposite sign, so no longer negative but positive, and flipping the value would be a 4/1. It also must pass through this xy coordinate 1, 7. So by using point slope, I have my equation to be y minus 7 equals 4 times x minus 1. This would be the equation of my line that is perpendicular to -1/4 x, but also goes through the point 1, 7. When you have 2 equations and you're wondering if they're perpendicular or not, notice how this second equation already is solved in slope-intercept form. We can see that the slope is a -4. To tell if this line over here is actually parallel or perpendicular, it's helpful to solve for y and get it alone sometimes, so we get the same slope-intercept equation. That is, if I minus 8x from both sides, I have -8x plus 12, and then divide everything by 2. That would give me y equals -4x plus 6. Now, notice how these two have the same slope. They actually happen to be the same line. But if this wasn't the case, we would just be able to note that our slopes are the same, so we could call them parallel. In this specific example, we note that it's actually the same line, but if it weren't, we would know that our slopes are the same. Remember, if you're ever having trouble, it can be helpful to graph these. You could have just graphed your equation in standard form and found your intercepts and then counted your slope. One last helpful example. They wanted 2 separate equations for a parallel line and a perpendicular line. To y equals -2/3 x plus 6. So if my slope is -2/3, my parallel line is going to have a slope of -2/3. My perpendicular line will have a slope of 3/2. Knowing those slope relationships is half the battle. From then, we know it has to include this point. So again, I would recommend point slope may be your best tool. Y plus 5 equals a -2/3 times x minus 3 would be for my parallel line. Sometimes we note parallel with those two slanted lines, as opposed to y plus 5 equals 3 over 2 times x minus 3. That would be for my perpendicular line. If someone wanted these in slope-intercept, of course, you could multiply your slopes through and solve for y. But keep in mind, parallel has the same slope and perpendicular has the opposite reciprocal slope. Go ahead and give number 8 a try on your review.